Okay, we've been working on parent graphs, parent functions all year, but let's just kind of refresh a little bit. So here you have a constant graph, a constant or constant function. That's when f of x is equal to any value, any number, any real number, I should say. And it can be written as f of x is equal or y is equal. So notice this one right here would be f of x is equal to 1, because where 1 hits the y-axis, there's a horizontal line. So constant functions go on indefinitely from negative infinity to positive infinity. So if you have to identify the domain of a constant in interval notation, well, from negative infinity to positive infinity. Now that's the domain. Remember, the domain are the x values. If it asked about the range, well, the range, it's stuck. It's not going up or down. The range is just 1 in a bracket because it's touching 1. All right, so this next graph is a linear graph, and that function is just y is equal to x, or f of x is equal to x. And notice it's indefinitely, not only is it indefinitely going up and down, so the range would be negative infinity to positive infinity, but the domain, so this is the range, the domain, while it looks mostly like going up and down maybe, while it's going down, it's going to the left, and while it's going up, it's going to the right indefinitely. So for the domain, it is also negative infinity to positive infinity. And notice it's the open parentheses bracket because you can't touch infinity. We never reach it. When you can touch one of the values, like in this example right here, you put a square bracket. So now we've got the quadratic equation. F of x is equal to x squared, y is equal to x squared. For the domain, what are the x's doing? Well, it looks like the graph is just going straight up. But remember, as this continues to go up, it continues to go to the right. And over here, it goes to the left. So its domain is negative infinity to positive infinity. Because look at, we can put any x value. This is how you tell. You can put any x value into x squared. You could put in 1 and a bunch of zeros squared. You're going to get a much bigger number. And same with the negative number. You put in a negative. There's nothing to restrict the x value that you put in here. So that's why the domain is negative infinity to positive infinity. All right, and the range, well, look at it, the parent graph, it bottoms out, it touches right there at 0, and then it goes upwards, up to positive infinity. And by the way, all of the x to the even graphs, this would be their domain and range. X to the even would all look like some version of this. And here we have x to the odd. Their domains and ranges are going to look very similar to this. So here we have a square root function. Notice it does not go on and on in both directions. So as we're looking at the x values, well, for the domain, the farthest left it goes, it touches 0, and it goes on to positive infinity. Well, let's look at the range. It also touches 0, and it goes up very gradually, but it continues to go up towards positive infinity. All right, and then x cubed, well, x cubed is odd, x to the first is odd, and if you notice, it infinitely goes up and down, and while this is going up, it's headed towards the right. This is headed towards the left. So all x to the odds The domain is negative infinity to positive infinity, and the range is negative infinity to positive infinity. All right, there's one other topic that we haven't really covered yet. This is the idea of increasing and decreasing, and where is a graph increasing and decreasing. So let's come back here and let's look at the constant graph. Well, it's neither increasing or decreasing. So you would say a constant graph neither increases or decreases. For this linear graph, remember you're always going to be reading left to right. Well, that graph is going up, so it is increasing from negative infinity to positive infinity. Let's look at this right here. Well, from the left, as we read left, right to this point right there, so from negative infinity up to 0, it is decreasing. And then now look what happens. Then it switches. It begins to increase. So that's the idea of increasing and decreasing. The cubic, even though we write these down arrows, but as we're reading left to right, the graph is going up the entire time. So increasing from negative infinity to positive infinity. And for this one, increasing from 0 to positive infinity. All right, that's it for this one.